Okay, today we'll have a presentation by group, okay, on the project. So at first you have to identify the problem and take a case study, and you have to use the advanced analytical model. So try to get a data set and provide detailed solution using deep learning techniques in artificial neural network. Okay, and then you have to provide step by step on how data be analyzed with deep learning, right? You can use this guide as a cross-industry standard process for data mining, where you can use for your project. Alright? And today we will have a project presentation with the project leader and the group members. Okay? Okay, thank you.
Good morning everyone, we are Group I and today we are going to talk about our project on rain prediction using deep learning model. I'm Alicia and I had the pleasure of working on this project with my teammates. They are Huai, Liqa, Mohammad and also Rewa.
Good morning, I am Alshweiki. Now I am going to introduction to abstracts of our project. This case study focus on developing a deep learning model to predict rainfall in New York using an artificial neural networking. That process seven meteorological attributes which are temperature, humidity, wind speed, precipitation, cloud cover, automation, pressure, and feasibility. It learning TensorFlow and cares. The model was trained cover 15 EVO with an 18 on 20 train test split and achieved an impressive accuracy of 93.15% and the test losses of 0.35. The objective included construction three-layer AANN, artificial neural networking, proposing a year's date from Kaggle and Rigol 3. Evaluating the model performance, laying the groundwork for deeper instinct into deep learning in the weather prediction.
Hello everyone, I'm Liqa Mohammad. Let's start with basics. Deep learning is part of machine learning that use multi-layer artificial neural networks to find complex nonlinear patterns in data. For weather prediction, it can automatically learn key features like temperature, humidity, and wind speed, which are challenging for traditional methods to handle. The problem we are solving is predicting rain tomorrow in New York. This is important for farmers, city planners, and early warning system. We are using an artificial neural network trained on historical weather data to make this prediction, helping overcome limits of old statistical models.
To begin our project, we started with installing Python. The steps is starting forward. First, we can download the installer from python.org and flow and follow the instruction given the most critical step during installation. Is to check the box that say added Python to path. This simplify the process of running commands later. I go to record libraries. Next, these are the record libraries and environment set up. We use it NumPy and pandas for data manipulation. Bolt clip to visualize our results with the graph and sketch learn for preparing our data for the model. Most importantly, we use it TensorFlow and cares, which is the framework we use it to validate our deep learning model.
Good morning, I'm Rewa Yones. Now I'm going to explain on deep learning using Python. So why did we choose Python for deep learning? Tools like TensorFlow allow for rapid prototyping and support for GPU acceleration, which speeds up training significantly. At its core, we built an ANN, which is a system of layered neurons that learns to recognize patterns. We use activation function RELU for the hidden layers and sigmoid for the output to help the model handle complex and nonlinear data. To build this, we used Keras, which works on top of TensorFlow. It allows us to define models sequentially, stacking layers one after another, then compile the model to configure the learning process and fit it to the data to begin training. We also use the Pandas library to load our data and scikit-learn's standard scalar to normalize it, which is a critical step before training.
I'll explain the deep learning functions that we use. First, we will use the sequential function to build the model layer by layer. The input shape comes from the training data. Then we added two dense layers. First is 16 neurons with ReLU activation. Second is 8 neurons with ReLU. The final output layer has 1 neuron with sigmoid to predict yes or no for the range. For training, we use model compile function, Adam optimizer, binary cross entropy as the loss function, accuracy as the metric, and to train the model, we use model.fit function to run the training for 50 epoch with 10% data for validation. For the evaluation, we use model.evaluate function to return the test loss and accuracy on the unseen data, and we use model.predict function to generate prediction probabilities for the new data. Here are some code snippets to show how we build the model. This code builds 3-layer neural network. First, we will define the input shape. Then we add the dense layers with ReLU and also sigmoid. To compile and train, we use Adam optimizer and binary cross entropy. We train for 50 epochs and save the result in history. Then we use evaluate function to test the accuracy and predict function to get the output. These functions are very important. They will help us to build, train, and also test the model.
So now let's talk about our data. It comes from rain prediction dataset on Kaggle, including daily weather observations for New York from 2024 to 2025. The original spreadsheet has details like data, location, minimum and maximum temperature, humidity, wind speed, and cloud cover.
And this is our system flowchart. It shows all of the steps from raw data to the final result. We start with the raw weather data, then we do data pre-processing, then we select the important features. We normalize it using a standard scalar, and we split the data into training and also testing. We build the NNN model, and we train the model for 50 epoch. After training, we do validation and testing. Finally, we will get results like accuracy and also confusion metrics. Each step is important to make the model work correctly. And then let's look at the learning process breakdown. Step 1 is the data preprocessing. We will remove columns like date and also location. Then we select features like temperature, humidity, and wind speed. After that, we will use standard scalar to normalize the data. Step 2 is model training. We will use a 3-layer neural network, which contains 16 neurons and 8 neurons with ReLU, and also the output layer is 1 neuron with sigmoid. We will use Adam optimizer, binary cross entropy, and also accuracy metric. We train using the model.fit function for 50 epoch. Step 3 is validation and testing. We will evaluate model with model.evaluate function. We will use model predict function to check the range prediction. We will also use our confusion metric to analyze the result. Let me explain our training step by step. First, we will load the dataset from Excel. We select the features X and also the target Y. Then we will do a train test split, which contain 80% for training and also 20% for testing. Then we will normalize the features using standard scalar, and we will build a 3-layer and then we'll compile the model using Adam optimizer, binary cross entropy for the loss function, and we will train the data. We train the model with 50 epoch, and also the batch size will equal to 16, with 10% data for validation. And all these steps will help us to build the model that will learn how to predict the rain. Here are some results and also observation. For the accuracy plot, you can see that the accuracy increases during training, and after around epoch 40, the accuracy becomes stable. It shows that the model is learning well. And now is the loss plot. The loss goes down over time. You can see some small changes in the validation loss, maybe a little bit overfitting. Now is the final evaluation. The test accuracy is around 85%, and this shows that this is quite good. And for the confusion matrix, it shows correct and also the incorrect prediction. This confusion matrix helps us to understand how well the model predicts rain. And for the training time, it took around 12 minutes on normal computer.
Good morning, Doctor. My name is Huai. Now, I will start my presentation on performance evaluation and model output. First, let's look at how our model performed. We built an artificial neural network, ANN, and trained it for 50 epochs. As you can see from the final test results on data that the model had never seen before, we achieved a high test accuracy of approximately 93.50% and a low test loss about 0.35. This is a strong start. It shows that our model is very capable of making accurate predictions on new data. Next, to ensure our model wasn't just memorizing the training data, we compared its performance on the training data versus a separate validation set. The final accuracy on the training data reached almost 99%, while the validation accuracy held steadily around 90%. The key takeaway here is the small gap between these two numbers, which tells us that the model learned that underlying the patterns well without significant overfitting. Next, I'm going to present all of the graph that has been used in our project. First, this graph visualizes the learning process. The darker line representing the training accuracy, it shows a consistent upward trend. Next, for the lighter line, it shows the validation accuracy. It also mirrors this trend closely. The fact that both of these lines move up together and then start to level off is a great sign. It means that the model learned effectively and reached a stable point of understanding. Next, similarly, this graph shows the model's loss or error over time. A lower loss means better performance. Both of the training and validation loss decrease steadily and then flatten out. This is exactly what we want to see, and it's confirmed that our model learned to minimize its errors and avoided overfitting. Now, let's break down the predictions with the confusion matrix. This table gives us a clear picture of where the model succeeded and where it failed. The high number of true negatives at the top left box means that the model was excellent at correctly predicting days with no rain. It was also quite good at identifying rainy days, shown by the true positive in the bottom right. Importantly, the false positive rate was very low, means the model is reliable and doesn't create false alarms by predicting rain where there isn't any. Now, I'm going to present about the results interpretation. There are three key takeaways from our results. First, the 93.15% accuracy confirms that an ANN is a very effective tool for this task. Second, we found that humidity, precipitation, and cloud cover were the most critical features influencing the predictions. And third, our model's architecture, specifically the use of ReLO activation functions, was successful in capturing the complex, non-linear patterns inherent in the rain prediction data. Of course, no model is perfect. Our primary weakness was a tendency for false negatives, that is, predicting no rain on days when it did rain. We believe that the main reason for this is the imbalanced dataset, which simply has more sunny days more than the rainy ones. This gives the model less data to learn from it when it comes to predicting rain, which is something that we can address in the future work. That's all from me. Thank you.
To wrap up, our three-layer neural network successfully predicted rain with high accuracy. While the model is strong, we see clear paths for improvement. In the future, we would like to use models that can understand weather as a sequence over time and train it on more balanced data from different cities and years. This would make it even more robust. So, in the future, we would like to use models that can understand weather as a sequence over time and train it more balanced data from different cities and years. This would make it even more robust. Thank you. Now it's the Q&A session. What the main challenge your model faced when predicting rain?
So the biggest challenge was dealing with the imbalanced dataset which only around 8% of the days had rain. Because of that, the model struggled more to correctly predict rainy days compared to non-rainy ones. So finally, here are the resources we used. The first one is Kaggle INC with the USA rainfall prediction dataset 2024 to 2025 from 2024. And the second one is Francis Chalest Deep Learning with Python First Edition from 2018. And the last one is Aurélien Giron's Hands-on Machine Learning with Skitslane Careless, and the last and TensorFlow concept tools and technical to build intelligent system from 2019.
Thank you.
Thank you.